This section should feel mostly like review from previous classes. I'm going to cover it here, and you'll have some homework on it, but please make sure that if you don't remember this from high school or 1P, that you plan to spend a bit of extra time this week to make up for that. The goal of this podcast is to give you the background to be able to interconvert between all of the units in your book. We've already covered a lot of these, and we won't be recovering them here. We'll talk about molality and doing parts per amounts. There is no reason to go through every one of these conversions, though, since they're going to be following the same problem-solving principles that we already know about with unit conversions. Of course, if you need more help remembering or learning the material, just stop by office hours. Now, we're going to look at molality a lot in colligative properties video, so we're not going to cover that super heavily here. So let's talk about our problem-solving practice. Think about this as playing with units. It's dimensional analysis. You do need to make sure that you know or memorize each type of unit. But what you don't want to do is memorize which direction you need to do the multiplication or division. You're going to use problem solving to do that. You're going to use unit conversion, dimensional analysis. You also should not memorize how to go between them. Don't memorize individual problems that if going from this unit to this unit, you do these 5 steps. That should be done by looking at your units and playing with whether they're in the numerator or the denominator. Do many example problems. This is going to be the best way to make doing this very simple and repetitive, and to the point where you'll almost get bored with it and will always get them right. So let's do an example where we look at mass percent. We're making a soft drink and we want it to be 11.5% sucrose. Let's organize all of our data and walk our way to the end. Let's first write out the 11.5% in more useful units. This becomes 0.115 grams of sucrose over the grams total. From here, we can look at the units and see that we need to be able to cancel out the grams total if we want to get to grams of sucrose. So let's use the density, which has the 1.04 grams on top and the 1 mil on the bottom. Now we are going to be left with grams per mil. So we need to multiply by the milliliters given in order to get our final answer of 42.5 grams of sucrose. The steps for this are not the important part. The important part is seeing how we were able to look at the grams total, get rid of the grams total, which was the thing that we didn't want, which now gave us milliliters, which we also didn't want, and then we got rid of the milliliters by multiplying by the mils given. And this idea of stepping through this is the most important thing to get from these videos. Let's do another example. Here we have a pollutant in water. Pollutants generally have a very low concentration, so we can use ppb or ppm. When we organize our data, we can convert the parts per billion into a more useful unit. So we know that we want to figure out how much water has 5 times 10 to the second milligrams. And we have the 15 times 10 to the negative 9th milligrams of chlorobenzene over the milligrams total. That's where that number came from. I just converted ppb into a unit that's more easily able to be used for dimensional analysis. Now, we could have used grams over grams for this as well, but it would have required another conversion step later on. We can also make a note that 1 gram per 1 milliliter, or the density, could also be represented as 1,000 milligrams per 1 milliliter. You may need to do this conversion out in a separate step. There's several other ways to denote all of this information. We could have converted everything to grams and it would have been okay as well, and there's a variety of other ways of doing it, just depending on your preferences. You just need to make sure that at the end of the day, all of your units match. From here, we start with our given or our desired number, the 5 times 10 to the second milligrams. We then use our ppb derived unit to cancel the milligrams of chlorobenzene, which leaves us with the milligrams total of the solution. Once we have our milligrams total of the solution, we can then use the density to convert between the grams into the mils. This cancels out our milligrams to get our final milliliters desired. We could, of course, convert this to liters if we wanted to as well, but in here we'll just leave it as milliliters. You need to be able to interconvert between molarity, molality, mole fraction, mole percent, percent by mass, percent by volume, parts per million, and parts per billion by either mass or volume. All of these are summarized in the table in your book. And remember to use this video as a problem-solving guide, not an all-inclusive guide to what you need to know. There is no reason to do every single one of these conversions here. You can work through all of these problems using the same principles of dimensional analysis. And if you aren't seeing that in just the few examples that given here, you can check online for other videos, or you can come in and talk to me in person, and we'll work through some of the problem-solving techniques together.